So this is the first lesson of Unit 3, and it's called Exponential Growth and Decay. So just to refresh your memory, maybe from Algebra 1, exponential growth looks something like this, okay? Like it's going to grow. It starts off kind of growing slow at a rate that's low or slow, and then it speeds up, okay? So that's exponential growth, and exponential decay is going to look something like this, right? So now this one it like speeds up over here, right? Slows down, slows down, slows down, slows down, slows down. All right. Um, so scroll, this is decay. All right. So before we go ahead and start the lesson, do some practice on rounding. And then we're going to go into our lesson on exponential functions and what that is. Um, four, this is supposed to be a four exponential models. You can represent it with the formula y equals a b to the x. So a couple of things that you need to know is that the a can never be 0. B has to be, this number has to be, if it's greater than 1, it's going to be a growth. And b cannot equal 1, otherwise it won't be exponential growth. So we're going to go ahead and do a couple of problems, but before that, so b, you might have seen it like this formula, 1 plus or minus r, and r is the rate of growth or decay. I think this might make a lot more sense when we're doing actual problems. But exponential growth, the formula is the a is the number that you're starting with. If it's growth, it's going to be 1 plus the rate, and x is time in years. And then exponential decay is not 1 plus, it's 1 minus, right? So 1 minus the rate. The a, small a, is still the starting. And so we talked a little bit about what the graphs are going to look like. So the a is positive and the b is larger than 1. This one a is positive and the b is a number between 0 and 1. Okay. So asymptote is basically a line that the graph can never cross. Like for example, in this case right here, right? If I draw the x-axis, the graph does never goes to negatives. And so the asymptote for a general exponential function is always going to be y equals 0, which is the x-axis. So this is the line y equals 0. And again, it can never cross into the negative for the general one. All right, so this is a visual about what asymptote is, right? Here's our green graph, and so it will never cross below -4. And this usually is the number that is the value for the asymptote. And then over here, this is y equals 2 to the x. That's an exponential growth because our number right here is greater than 1. And so the asymptote is going to be this line right here, which is y equals 0. Okay, because this is plus 0 here. All right. So here's an actual problem. Suppose you deposit $1,000 in a college fund. So this is our starting amount. So our small a. In a college fund that pays 7.2% interest. So first thing we want to do is move that to a decimal. So 2 places to the left. So 0.072, right? If there's no number here, there's an imaginary 0. There's a decimal point, and it's compounded annually, which means that it happens once. Okay. All right. Find the account balance after once a year, basically. Find the account balance after 5 years. Okay, so we're going to go ahead and just plug this in. So here's our R, and we want to find the account balance after 5 years. So that's going to be our X. Our X is equal to 5. So let's go ahead and substitute values in. So 1,000 is A, small a. Our R is 0.072. Why did I write my 0 like that? I have no idea. And our X is equal to 5. So now we're just going to go ahead and plug the numbers into this. So A equals, right, the amount that we have after 5 years is going to equal our starting amount, which is 1,000. And all I'm doing is plugging numbers in here, right? Parentheses 1 plus RR, which is 0.072. And we're raising it to, right, that's that. And we're raising it x equals 5. So I'm putting a fifth power here. So now I'm going to go ahead and grab my calculator, and I want to walk you through one from scratch. So 1,000, right, parentheses 1, since again this is growing, there's interest here. So I'm going to do plus 0.072, close those parentheses, raise it to the, right, this little mountain symbol above the division symbol, and we're putting a 5 here, okay? and then when we hit enter, we get 14, 15, and then we wanna, it doesn't tell us what to round to, so since this is money, let's round to the nearest penny. So 14, 15 point, I think it's 70, let's see. So that 8 makes that 0 go up to a 1. Okay, so since this is money, here is how much is in the account after 5 years. Okay, so based on the graph, which expression best represents f of t? So first thing that I notice is this is a decay, right? It's going down from when we're looking from left to right. The graph is going lower, right? So I know that the initial number doesn't matter, but I know that this number right here, the number in, well, in the parentheses, has to be a number that is less than 1. So let's see, right? So this is not even an exponential function, right? This is linear, so that's automatically out. So it's going to be this, this, and this. We could go ahead and graph each of them, right? So it says which best describes. We already got rid of one of them. So I'm going to go ahead and take my calculator. Let's move her over here so I can actually see it. And so I go like this, and I'm just going to clear whatever is there right now. You should do the same. So I'm going to put in 35, parentheses, 0.76, close parentheses, to the, and instead of t, I'll just use x because it's a little bit easier. And then I'm looking for these numbers, right? 220.75. So if I go to my table, right, 220, I don't see exactly 20 there. And then 75, don't see it exactly, right? It's kind of close. See 215.364. Right, so I know that that cannot be it. So if I go over here, I'm going to go ahead and get a little bit more exact. 34.88 parentheses. I should have erased it, but I didn't. 0.7584. Right, close those parentheses, and it's still raised to the x. Just make sure I typed it incorrectly. And again, I'm looking for those two numbers, right? So 220, it's getting a little bit closer. And 75, again, it's getting a little bit closer. Okay, so far right now, between the two of these, 2 and 3, it's 3 is a better answer than 2. So let's plug in the last one. Clear that. I have 80. That doesn't look right because our starting number, but let's just go ahead and plug that in. Parentheses 2 to the negative x. And go over here. And again, I'm just going to check this. So do I have, okay, I have exactly 220. And then over, do I have 7.5? I don't have 7.5, right? So yeah, that one's out. So the closest answer that we have, it says best defines, is going to be option number 3. Okay, so do this check for understanding. Remember, depreciates is not a growth, it's going to be a decay. So we're going to decide which formula to use, right? A equals A, it's going to be 1 plus or minus r to the t. So go ahead and plug that in and see which one you get. Okay.